Welcome back for the final session. Okay. Marissa, you want to read problem number 8?
Yeah, so in your book, and we're on page 519 here, it says, an RC series circuit is connected to a 240 volt 60 hertz power source. An ammeter indicates a current of 20 amps, and a wattmeter indicates that the circuit has a true power of 3 kilowatts. What is the circuit power factor, and what is the capacitance of the capacitor?
Well, what you've got here is an overflow of information, all right? And you can see the first thing I went after, ultimately I didn't need. The next thing I went after, I did use, V sub R. I did need VA. Okay, so I ended up wasting time doing a calculation that I didn't need to do. But the nice thing about that is it told me that some of the information I came back with appeared to be in the ballpark. All right, so with that in mind, let's get down to it. Here they're asking for the power factor, and they're asking for the capacitance of the capacitor. All right, so ignore the first step, and we'll call the next the first step, right? So this is number 1, actually. All right, so because we've got the current, which is actually equal in all parts of the circuit because it's a series circuit, right? I can calculate, because they've already given me the power right up here, and they've given me now the current. So I have those two values. And when we plug those two values in there, and again, that's total, the true power, which is P, divided by the current through the resistor. And when we plug that in, we get that the fact that 3 kW, again, K stands for 1,000, so it's 3,000 watts divided by 20 amps, all right? And when we plug those numbers in, we get up 4,800.
No, we got 150.
Whoops, sorry. Whoop, missed the line. So we end up getting 3,000 divided by 20. We can cancel out. We get 300 divided by 2, which is 150 volts. Okay, makes sense. All right, because I've got a total voltage up here of 240. So obviously this has got to be lower than that. So now that I've got that figured out, the next thing I'm going to go after is the VA. Why? Because the VA is something related to the true power where I can calculate the power factor. So with that in mind, I'm going to go after VA, and VA is going to be the total voltage times the total current. All right, so that's 240 volts times 20 amps, which is 4,800 kVA, or which is 4,800 VA, which works out to be 4.8 kVA. All right, so with that in mind, now I'm in a position to actually calculate the power factor, which I've got P, which was a given, and we calculated VA. So the P that was given was 3 kW. We calculated the VA, which was 4.8 kVA, all right? And now at that point, we're left with the K's cancel out. 3 divided by 4.8, which comes out to be 0.625, all right? So, or another way of expressing that is you can times it 100, and you could say 62.5%. All right, but either way, it's the same number. It's just a matter of whether you're expressing as a fraction or whether you're expressing as a percentage. All right, and this is where I found out that I didn't need this other one. Okay, so now I figured ultimately I need to get the reactance of the circuit to be able to figure out, all right, so to be able to figure out the capacitance. So with that in mind, we're looking at, again, a Pythagorean theorem here. The fact that the one that I'm looking for is going to be equal to the total squared minus the resistive voltage squared. All right, so now I've got 240 squared minus 150 squared, and it came out to be
35,100. And we're going to find the square root of that, and that works out to be 187 volts.
And again, it makes sense. All right, because the total voltage is 240, and now 187 volts, I expect it to be somewhat lower. Now, having calculated that, now I can calculate X sub C. All right, and now I've got V sub C divided by I sub C, which is going to be 187, I just calculated, 20 that was a given. All right, so 187 divided by 20, put it in my calculator, and it came out to be 9.36 ohms. Now, up here, when I calculated Z, 9.36 compared to 12, all right, I expect Z to be higher, so therefore, in this case, it makes sense, all right? But now I've got the information I need to be able to do my final calculation, and that is the fact that the capacitance is equal to 1 divided by 2 pi frequency divided by X sub C. Make sure that you don't get that wrong. All right, so now I've got, again, 377 because it is at 60 hertz, and that was a given, times 9.36 that I just calculated, and it comes out to 1 over 3,530. And when I plug that in and do a 1 over x, I end up getting 0.000283. All right, I've got six decimal places here. 1, 2, 3, 4, 5, 6. So therefore, I could express that as 283 microfarads. And that is it. Okay, guys, we're going to have another part that you need to do here. And so you need to go to the next stage, look at your discussion there. There'll be a question in place for you to answer a question. And again, that's going to get you attendance for the day and whatever else. After that, I'm going to want you to work on your project. And again, that's spelled out in there. So when you go to your Canvas, okay, first off, you open up your subject, you scroll down to week 4, and you're going to see that everything is pretty much in order. Day 1, day 2, day 3, day 4. We changed it around that way to make it a little bit easier for you guys to be able to figure out what's going on. So with that in mind, carry on. I'm going to check the email, make sure that there's nobody having problems, and check what's happening on Canvas. And good luck. Stay healthy, guys. Thank you.